Is it live now? Hello? Live now? Okay, fine. Hello, everyone. Now I am in live session. If you have any queries, you can ask me. As such, you have not yet submitted any what it's called queries in Excel sheet. That's why now if you are live, then you can ask me any questions if you have any doubt in this course. Yeah, first of all, little bit I want to again introduce about this course. This course name is Fundamental of Thermo-mechanical and Fatigue Analysis of Welded Structure. This course is really a very interesting course. It is you can say related to little bit advanced level course. In this course, you will get a very high fundamental knowledge on what it's called thermal analysis related to welding process. You will also get the fundamental knowledge on what are the design concept, then mechanical analysis of welded structure. That related things also you can get from this course. Apart from these things, you will get the detailed concept, which is a most important concept that is related to fatigue analysis of welded structure. That related things actually I have covered in this course in
Get the
details.
fundamental knowledge on what are the
So
design concept, then
now
mechanical
I'm
analysis
again briefly
of
introduce
welded structure.
about
That
the
related
course
things also
content,
you can get
which will be
from this
really
course.
helpful to you.
Apart from these things, you will get the
Here,
detailed
the content
concept,
of the
which is a most
lecture, you
important
can say,
concept that is
are
related to fatigue.
first of all, I have discussed about concept of different types of numerical method used in welding analysis. Then I have discussed about a governing equation of thermal analysis, how the governing equation came for doing thermal analysis. That related things actually I have derived in this course. Actually, this is really a very basic fundamentals, and here I have discussed the detailed derivation of different types of thermal analysis related concept, mechanical analysis related concept, as well as fatigue analysis related concept. Apart from these things in this course, I have also covered this creep of fatty creep of welded structure. That related things also I have discussed in this course. So here, generally, I have discussed about, I have told you governing equation of thermal analysis. In this governing equation, generally what happens, how this governing equation come, or the detailed derivatives actually I have presented in this course, which have already completed. Apart from this thing, in this course, I have discussed about fixed heat source in case of welding. Generally, initially, whatever the welding thermal analysis was done analytic by using some analytical method, there generally researcher use some fixed heat source. That fixed heat source are generally, one is called point heat source, another one is called line heat source. Due to this point heat source and line heat source at a particular location, if you apply, then due to the what is called thermal conductivity, what is the temperature distribution will be over the entire plate or over the entire structure. That related things actually I have discussed in this course initially. Then I have discussed about the concept of moving heat source, which is a very important you can say topics related to welding thermal analysis. There I have discussed about what it's called concept of point heat source, moving point heat source related things in details. So during discussion of this concept of what it's called moving point heat source related thing, there I have discussed about what it's called quasi-stationary, Rosenthal quasi-stationary moving heat source related concept. So here generally how this quasi-stationary governing equation came, that related derivation I have discussed in details in this course. Then I have gone to discuss about what is called moving heat source, both for two-dimensional and three-dimensional case. Then I have also discussed about fundamentals of cooling rate, then preheating temperature calculation. That means what is the effect of preheating as well as cooling rate on thermal history, as well as you can say welded final structure. That related things I have discussed. And what should be the basic concept for getting a sound well quality, what should be the basic fundamentals concept required for cooling rate as well as preheat temperature. That related things in details I have discussed in this course. In addition of the above topics, I have also delivered lecture on the fundamental of different types of welding heat sources, models, and their derivation and importance, you can say. Because you see, nowadays welding simulation is a very popular research topics. So for doing the welding simulation using some commercially available software package like finite element method like ANSYS, Abacus, SysWeld, or some other what it's called COMSOL, or some other finite element software packages, they are generally for doing well introduce thermomechanical analysis, what are the basic concepts required, that related things in details actually I have discussed. For those basic concepts, generally in welding analysis, the most important topics is heat source modeling. If you, because if you will not use proper heat source model, then what happens, your analysis will not be matching with experimental results. That's why what happens, I have discussed here different heat source model and how those heat source model came. That detailed derivation actually I have presented in this course in details. And I have discussed about both two-dimensional heat source model as well as three-dimensional heat source model. In two-dimensional heat source model, I have discussed about Gaussian distribution of heat flux, and where is the application of this Gaussian distribution of heat flux. That related things in details I have discussed, and this derivation also I have presented clearly. Yeah, Probin, do you have any queries? If you have any queries, you can ask me, right?
Yes, sir. Good afternoon, sir.
Yeah, very good
So,
afternoon.
yeah,
Yeah.
your course is very informative and a lot of things I can learn from it. Uh,
Yes.
okay,
Thank you.
what is the software we will be using, sir? Any software we will
Actually,
use? Yeah.
yeah. Frankly speaking, actually, for doing thermomechanical analysis,
Yes.
I was trying to cover software related things also. Like I prefer to use ANSYS or Abacus software. But
Okay.
frankly speaking, due to time constraint, that part is not able to cover in this course. But I
Okay.
have given the detailed fundamentals things
Okay.
actually, and in between this discussion part also I'll discuss those things, how to use those software. Okay, in
Yes.
this live
Yeah.
session also I'll show you some PPT, how to do the thermal analysis using this
Okay.
fundamental concept, as well as how to do the mechanical analysis using this fundamental concept. In details I will discuss.
Okay.
Mainly I prefer to use ANSYS software, otherwise Abacus software, because these two software have a wide acceptance
Okay.
in worldwide. What I'm telling
Mm.
others, that's why what happens, and these two software you can say, here you can use your own what it's called innovative types of idea also, because here
Okay.
you can generate your own code. What I'm
Yes.
telling,
Yeah.
understand?
Yeah. Yeah.
That
User defined subroutine.
user defined subroutine. Yes, very
Yeah.
good, you know
Okay.
this thing. So
Yeah.
that's why what happened, instead of using csweld and other things where generally there is that types of informative things generally, or that types of, you can say, innovative things, you will not get. What I'm
Yes.
telling, understand? They are
Yeah.
generally straightforward. This thing is inbuilt already there. So that's
Yeah.
why I prefer to use here ANSYS software or Abacus software. Okay.
Yes, sir. Sure.
So that
Sure. If you
related
can
things. Yeah,
Yeah, if you can do some demos, it will be really very helpful
very
for us.
definitely,
So,
definitely. I'll do the demo for you.
yes.
And what happens today itself, I will give you some fundamental things for doing
Oh,
this numerical analysis. What are the
oh,
actually things required? What is the basic concept first you need
oh,
so that your
mhm.
analysis should be appropriate? What I'm telling,
Oh,
understand? That
yeah.
related things I
Yes.
will discuss in today's lecture itself. So
Okay.
if you
Thank you, sir.
want now itself, I can start that demo. Okay,
Yes, sir.
little bit I
Okay.
am just telling you. Bhavin, you
Okay,
are
sir.
from
Thank
where?
Uh, I am from Gadi Shakti Vishwavidyalaya. It is a central university in Gujarat. We work under Ministry of Railways.
Okay, okay,
So
okay.
it is a one of its kind university where we work on transportation and logistics sector. So
Very good,
uh,
very good.
yeah, we have all our courses curriculum design where 70
Hmm.
percentage regular courses will be there, either mechanical,
Uh,
electrical, civil, and 30% students study railway related courses.
okay, 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 okay. That means
Mhm.
70% course from. Yeah.
Mechanical, their core curriculum they will study. Either if it is BTech in mechanical, 70
Hmm.
percentage will be mechanical courses.
Oh my
Remaining
God, got it, got it.
30
Yeah.
percentage will be railway related courses like rolling stock and the signaling system like that they will study.
Okay, 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 okay. You are engineer in that,
I am a
or you are
PhD in
teacher?
mechanical engineer. Yeah,
Okay,
I'm
okay.
PhD in mechanical
You did
engineer.
PhD from which university, right?
Homi Boba National Institute.
Okay, Bhava National. Wow, very good,
Yeah, yeah.
very good, good. And actually, you see, I don't know in this course actually as it is started very newly. That's
Mhm.
why I think actually the course registration actually I have seen little bit less, but in
Okay.
my other courses the registration is very high. But
Okay.
I actually, in my opinion, frankly
Mm.
speaking, this course is the, you can say, one of my very best course where
Yes,
you
yeah.
will get
Mhm.
so many things because I have
Mhm.
tried my level best to incorporate all the derivation and all the things very
Yes.
nicely, frankly speaking.
Okay. Yeah.
So I think this screen is
Yeah.
visible, correct?
Yeah, yes, sir. It is
Okay. It is visible. It is actually in your where you are working. Is it a institute or
yeah, it is
railway
central university, sir. It is a central
university? Okay.
university. Yeah,
Very
but
good.
it
Very good.
doesn't comes under
Uh,
Ministry of Human Resources. It comes under Ministry of
got it. Got
Railways.
it. Very good. Understood. Okay, fine. Okay, I'll just little bit discuss actually about
Yeah.
these things. Then it will be very clear to you.
Okay.
Generally, for doing any types of analysis by using commercially available software packages, first and
Mm.
foremost thing, what you need to know. First
Mhm.
and foremost things you need to know I'm just one by one I'll discuss, then it will be very clear to you. Just here I am writing the things. Then for doing any types of analysis, first and foremost things you need to know what is the governing equation. What is the, I am writing these things, governing equation.
Yes, right.
So governing equation for, you know that for welding thermal analysis, I have already told you that is
Mm.
generally Fourier heat conduction equation. That is in case of three-dimensional case, you can say del 2t by del x square plus del 2t by del y square. I have also derived
Yeah.
this equation del
Yes.
2t by del z square is equal to your, you can say 1 by, you can say alpha, that is thermal diffusivity, del T by del T. Correct? These
Yes.
things
Right.
already I have
Yeah.
told you. So
Correct.
here this governing equation, first and foremost things you need to know what is the governing equation
Mm.
generally used for doing any types of analysis. So you got the idea. This is the governing
Yes.
equation. This
Yes.
governing equation generally gives you the all knowledge for doing the analysis, that you can say. What
Yes.
I'm telling, understand? Like
Yes.
here the output is, so here the output in this governing equation is temperature.
Temperature.
You know
Right.
this, that is the
Yeah.
output. So for getting that output, you need to know what other things you need to know. Do you see whatever the other parameters are there in this equation, all will be your input. What I'm telling,
Inputs.
understand? Yes,
Yeah.
all will be your inputs. So here the inputs are like here I am just showing. Here the input are generally coordinates x, y, z is required one
Yeah.
things. Then your
Material
another
properties.
another paper what it's called parameter
Time.
is time. That is
Time. Yeah.
generally incorporate the velocity of welding. That is and another things is alpha. You see thermal
Yeah.
diffusivity.
Yeah.
Alpha you know that is actually K by rho
Rosy.
Cp. Rho C.
Yeah.
Yeah, very good. You know this thing. So you see, so this information is first and foremost things you need to know. That means you need to
Mhm.
put K is called thermal conductivity.
Yeah.
Thermal conductivity. I am writing. Then
Okay.
rho is called density
Density.
and Cp is called specific
Specific heat.
heat. These are the
Yes,
things
right.
you know. So,
Yeah.
so what happens in your thermal analysis? If you will means forget to put any one of the material property, then what happens? Your
Mhm.
result will be erroneous. First and foremost thing you
Yes.
need to know. So you
Okay.
got the idea from the what is called governing equation itself. What are the input parameter required to do the thermal conductive? That means transient thermal conductive analysis, thermal
Yes.
conduction analysis. So that idea for doing these things, what are the input and output are required, that idea you got. So here
Right.
generally let us consider you are going to use steel material. So steel
Mhm.
material and you are going to do the welding in a steel plate.
Mhm.
Let us consider this is a
Okay.
plate. I am just little bit. So this plate is your input parameter, correct? Plate give you the
Right. Yeah.
coordinate, all the coordinate. This all the coordinate will be provided by the plate. And here your
Right.
input of this material is, if it is steel material, okay. So you need to specify all this steel material, thermal conductivity, rho, Cp. You see,
CP.
in your
Yeah.
analysis, if you will not put this rho, then also it you will
Mhm.
get some result. But what happens? That
Okay.
result will not be very appropriate. What I am telling, understand? This you should
Yeah.
keep
Yeah.
it in
It's
mind.
not reliable. Yeah.
It will not be reliable one, because
Yes.
what happens, because it's still it will take some whatever its owner define density, what I'm doing the
Mhm.
analysis. But if you will
Yes.
specify the density for, let's say, steel, what I'm telling, and
Mhm.
you still have a one types
Yeah.
of density, aluminum have another types of density, copper has
Correct.
another types of density, titanium has another. So different materials, different density. So that's why its effect also, this alpha effect also will be different on temperature output, correct? Whatever the
Ye-
temperature will be there in this output, its effect will be different. So that's
Yes.
why what happens, I have seen most of the cases whenever the researchers go for doing this thermal analysis of welding process or any analysis of welding process, they generally always try to avoid to put this density. But
Mhm.
you can imagine that density also have a effect. This is one
Yes.
thing.
Okay.
So this property, once you use in your analysis, once you use in your, that I will show you in details step by step using ANSYS or using
Okay.
Abacus software, how
Okay.
to do what is called finite element analysis and to get
Mhm.
what it's called output, that means thermal history as well as residual stage, distortion and all the things, that
Okay.
related things in details actually I will discuss in subsequent live session. What I'm telling,
Okay.
understand?
Yes.
Because that part I could not able to incorporate in this course due to time constraint, that you can
Okay.
say. What I'm telling,
Okay.
understand? But that
Yes,
I
sir.
will cover here in live session. Now here see, uh, now you can do the analysis, you can solve this, because in this software generally they solve this software solve this equation only, this governing equation only. What I'm
Mhm.
telling, understand?
Yes, sir.
Now here one things you should keep it in mind, this material property which I have told you, that means K rho Cp,
Mhm.
this you can put in two way. One is called temperature independent, or temperature independent, another one is called temperature dependent. What I'm telling, understand? Because
Yes, sir.
this
Yeah.
material,
Uh,
is this material property K rho, Cp,
Yeah, all
it's
a function
varying.
of temperature. Yeah,
Yes, all are a function of temperature. This you
temperature.
should keep it in mind. This is a
Yes.
function of temperature. Now, let's what happens in your analysis if you use a constant property of K, rho, and Cp. Then what happens? Your result will be again not reliable, and it will give you results. But what happens? Which will not be appropriate one. What I am telling, understand?
Yes,
These are
sir.
the things you should keep. That's why for doing the analysis, you need to consider temperature dependent material property. If you use this temperature dependent material property, then whatever the transient thermal result generally you used to get, that will be very just one transient thermal profile I am drawing. As you are well familiar with all these things, that's why this is your time, this is your
Mhm.
temperature. So with time, how the temperature profile is varying, you see
Yeah,
this
yeah.
temperature profile generally will be matching with experimental one once you will use the input parameter correctly. This you should keep it in mind.
Uh,
Okay, this input parameter, if it is a temperature dependent input parameter, you will get more accurate results. What I am telling, understand? Then if you use a constant material property as a
yeah.
input, what I am telling, understand? This you should keep it in mind. That's why what
Yes, sir.
happens, using constant material property, you can observe that you will get a thermal profile, but it is coming like this. What I am telling,
Mhm.
understand? Which is
Yes,
not
sir.
exactly the things which is
Real behavior.
happen in
Yeah.
real behavior. What I am telling, understand?
Right.
So these are
Yes,
the
sir.
things you should keep it in mind. Apart from
Mm.
these things, here generally in this weld surface, actually what happens? This weld surface is subjected to what? This weld surface is subjected to some contact with atmosphere, correct? Due to this
Yes.
atmospheric contamination, I have already told you, generally
Mm.
this weld surface is subjected to some boundary condition, you can say, or heat loss it is subjected to. This heat
Mm.
loss is generally occur due to convection and radiation. You know these things,
Yes. Right.
radiation. So that's why what happens. So this convection and radiation related again boundary condition you need to know. What is convection and what are the things required for applying convection in a particular object or in a particular surface. So
Yeah.
that's why you need to know actually
Uh,
convection governing
heat transfer
equation again.
coefficient. Yeah. Yeah.
Yeah,
Yeah.
yes, convection equation you need to know. So
Mm.
convection
Mm.
equation, convection heat loss, let's
Shade.
QC ASF into T minus, yes, very good,
Yeah.
T0.
Yeah.
This
Infinity. Yeah.
also correct?
Yeah. Right.
So here generally temperature is already known to you. You can say that you are getting from this governing equation,
Yeah.
correct?
Yes.
So and T0 is the initial temperature, which is the room temperature. T0 is the initial temperature of the plate, which is actually you can say room temperature, which can be 25 degrees centigrade.
Yes.
What I'm telling, understand? Depending
Yeah.
upon your season, it can
Yeah.
different. During
Yeah.
cold time, it can be 10 degree. During hot
Yes.
time, it can be 35 degree also. What I'm
Yes.
telling, understand? That you
Yes,
need
sir.
to specify. And now you see to incorporate this convection boundary condition, then what are the input parameter required and where the convection is taken place, that also you need to know. So
Mhm.
convection generally taken place in all the surface. You see this surface S1, S2, this side also surface is there, S3, S4, and bottom side also some surface is there. What I'm telling, understand?
Yes,
But
sir.
bottom side surface is contact with some, what it's called, you can say metallic types of, if it is metallic types of surface, there the convection coefficient will be different. Depending upon
Different.
the medium to
Surface.
medium, this
Mhm.
ASF value will be different.
Different.
That
Yes.
also you need to specify very accurate way. What I am telling,
Mhm.
understand, during your analysis.
Yes.
Otherwise,
Yeah.
your result will not be accurate one. Okay. So this is one
Yes.
boundary condition. Another boundary condition is called radiation boundary condition. So radiation boundary condition, that heat
Yeah.
loss equal to
Yeah.
emissivity
Stephen. Stephen.
into Stephen coefficient into
T
Boltzmann
prof.
Stephen coefficient into T to the power 4 minus
Mm.
T0 to the power 4. Correct?
Yes, sir.
So for doing these things, what are the input parameter required? Epsilon
Yeah,
emissivity you need to specify. Boltzmann constant also you need to
yeah.
specify. Okay. So you
Yes, sir.
see, without all this information, if you will do the analysis, your result will not be accurate. This is the first thing. What I am telling, understand?
Yes, sir.
Second thing, now what happens? You are doing welding, correct? So welding
Yeah.
means there will be some heat source,
Mm.
correct? So that
Yes.
heat source will move along the, you can say, weld line.
Yeah.
Is a continuous moving will be there, correct?
Yes.
Now this heat source modeling is a most important part in your what is called welding simulation.
Okay.
That related things in details I have discussed, that you can say. I
Yeah.
have discussed, Jen, or let's what happens if you will go for doing some laser types of heating, only laser
Mm.
heating, not laser welding. So there you can use only simple Gaussian distribution of heat flux, two-dimensional
Mm.
heat flux. But once you
Okay.
go for doing what is called well deposition related things, let's well bead is depositing. What I'm telling, understand? If you take the cross section here, if
Yes.
you take the cross section, you know
Yes.
your well bead geometry can be like this. Your well bead geometry can be like this, correct? Well bead cross section, top reinforcement as well
Yes,
as
sir.
bottom
Yeah.
reinforcement. So your well bead geometry can be
Mm.
like this.
Yeah.
Now this well bead geometry,
Mm.
to incorporate this well bead geometry, and while the heat source is moving, generally what
Mm.
happens? The heat
Mm.
source generally take a shape which is looks like double ellipse. What I'm telling, under which is looks like
Yes, sir.
teardrop shape. You can say teardrop shape due to movement of the let's, this is your electrode post central line, this is let us electrode central line. Once it has a speed v, velocity, then what happens? It take a shape which is teardrop types of shape, correct? That I have already told you. So what happens? So that's why you see, once you divide these
Yeah.
things into two part, you can resemble this thing. Front part of this teardrop shape is one types of ellipse, and
Okay.
backside of this teardrop shape has another types of ellipse, correct?
Okay. Yes,
That's
sir.
why I have told you, generally for doing three-dimensional types of analysis,
Mm.
three-dimensional types of heat source modeling analysis, it is
Mm.
better to use for normal, whatever the conventional different types of welding process are there, like submerged arc
Mm.
welding,
Yeah.
then what happens, MIG welding, TIG
Mm.
welding, what I'm telling, understand?
Yes,
Plasma
sir.
arc welding, these are all very conventional arc welding process. They are
Mm.
generally, you can use these types of double ellipse types of heat source model with
Okay.
what happens? Backside, generally, what are the things are there at the depth position? Its shape is like this, correct?
Okay.
Its shape
Yes,
is
sir.
like this,
Yeah.
which is called double ellipsoid. What
Yes.
I'm telling, understand?
Yes, sir.
At top surface, it's look like two different ellipse,
Yeah.
and what happens, bottom side generally, it's as it has a height. That's
Yeah.
why what happens, it is a
It,
in three-dimensional case it is called one
ellipse.
ellipsoid in
Mm.
ellipsoid.
Ellipse
So
side.
one
Yeah.
ellipsoid,
Yeah.
three-dimensional name is called ellipsoid. So one
Ellipse
is
side.
front ellipsoid, another one is back ellipsoid. So
Back.
two
Okay.
ellipsoid you can get. This is one ellipsoid, this is another ellipsoid. So
Yes, sir.
these things is proposed. This double ellipsoidal heat source model is a very well established and well accepted, you can say, heat source model for
Mm.
conventional types of, whatever the conventional types
Welding.
of welding process are there. For
Mm.
that, generally, it
Mm.
is very well accepted one. What I am
Okay.
telling, understand?
Yes, sir.
1 minute. New slide I am just doing. So that's why this double ellipsoidal model, how to model these things in details, I have discussed in my course, that you can already observe. That means how
Yes.
this double ellipsoidal heat source model is coming, and how to how that this moving coordinate heat source generally you need to specify in your analysis that related things I have discussed in detail. The like here I am writing this thing.
Mhm.
Generally, double ellipsoidal heat source model you can write. It has two part. One is front part. This front part is 6 root 3. Can you recall this thing?
Yes,
Eta
sir.
into Q into FR divided by you see pi root pi A B C R into exponential to the power minus 3 x square by a square plus y square by b square plus zeta. Zeta is the moving heat source. Let z direction is moving heat source by
Mhm.
c square. This
Oh,
FR generally represent for front part. Similarly, for rear part, all the same. Only FR will be FF. And rest
oh,
of the things will be same.
mhm.
And
Yes.
CR will be just CF. Okay.
Oh, okay.
Now, what is FR and CF? That related things I have already discussed in
Mhm.
details. That
Mhm.
once you'll go through this, there you will get. So this equation here generally this equation generally is a function. This zeta moving heat source. This zeta is a function of what I have already told you: velocity and time t that
Time.
you
Yeah.
that you can observe. Okay.
Mhm. Mhm.
So
Yeah.
with the velocity, so with this velocity and time t, how the moving heat source is moving, that
Mhm.
related the little bit here I am writing. Zeta generally you can write as z plus v into tau minus t. Can you imagine? Can you recall these
Yeah.
things?
Yes, yes,
I have
yes, sir.
already discussed these things. So
Yeah.
here generally tau is called moving coordinates
Mhm.
along z direction or moving direction. This is generally moving coordinate, and this
Yeah.
z is generally fixed coordinate system. Fixed coordinate system. V
Yeah.
is called
Mhm.
oil velocity, and tau is called lag factor. I have already told you
Yeah.
details in details, and t is called time.
Yes.
So with time, generally you see this zeta is varying. That means along the well line, this
Mhm.
double ellipsoidal heat source model will moving
Yeah.
with this what is called z direction like this by using this
Oh.
equation. What I'm telling,
Mhm.
and that things in
Yes, sir.
details I have already discussed. So
Correct. Yeah.
this volumetric heat source model generally,
Yeah.
yeah, once you will incorporate and do the simulation using what it's called the finite element method like ANSYS or Abacus, you will get very accurate result. You can't imagine within a percentage of error within 5 to 10% only. And we have done these things here, and we have checked. Yeah, really, it's give us a very wonderful result. So this is generally for conventional types of welding process. This technique
Okay.
is very popular. But for
Mm.
laser, electron beam welding purpose also I have shown some another types of model. I think that is also you have covered also. Some other types of heat source model. They are generally instead of this double ellipsoidal one, they are generally what happens conical, hybrid types of heat source model, conical then cylindrical. Can you recall that things?
Yes, sir. Yeah.
That
Correct.
type
Yeah.
of heat source model generally they are you need to use. Why? Because that heat source generally laser or electron beam, that heat source is very high intense heat
Mhm.
source model. What I'm telling,
Correct.
its heat
Correct. Yes.
intensity is very high, so
Very
its
okay.
depth of penetration also very high.
Very
What
high.
I'm telling, understand? That's
Correct,
why what
sir.
happens throughout the entire plate, this is a plate. So what happens in this plate, throughout the plate thickness generally you can get a bead which is throughout the entire region, which is more or less uniform in nature. What I'm telling,
Mhm.
understand? Due to this high
Yes.
laser intensity that you know very well. So that's
Yeah.
why they are generally this heat source model will be different. But for
Mhm.
conventional purpose, SMAW, submerged arc welding, then TIG welding, MIG welding, they are generally what happens. This double ellipsoidal heat source model is very popular. This you should keep
Okay.
it in mind.
Yes, sir.
And this whatever the things I have shown, this XY zeta, you can write your what it's called subroutine. What I'm telling you,
Mhm.
this heat source model, only this subroutine you need to write. So once
Okay.
you know this fundamental concept, how the heat source is moving with respect to a stationary coordinate, how the moving heat source is moving, that I have discussed in detail. If you know this thing, you can easily be able to write what it's called
Subroutine.
subroutine. What I'm
Correct.
telling, understand?
Yes.
Now, this is generally this fundamental thing generally I have discussed in this case, in this course in details. And what happens in some live session, I'll show you how this subroutine is coming, what I'm telling, understand, how to write the code, how the how to this define this parameter, what is a, what is b, what is c. And I have already shown you that how this a, b, c generally you need to find, these are all constant. How to find out these
Correct.
things, little bit I am just discussing. Generally this you need to define from experimental observation.
Experimental
I have,
fitting. Yes, sir.
yes,
Yeah,
yes.
fit.
So
Yeah.
once you do the welding, you observe that once it's complete the welding process at the end, there generally creates some crater. Crater, what does it means? I have already discussed. Crater means some depression, the actually depression of the what is called weld bit due to weld solidification and its shrinkage. At the end, generally, once you do the welding, you can observe there occurs some crater types of shape. Can you recall these things at
Yes,
the
sir.
well?
Yes, sir.
Yes. So this
Yeah, crater.
scatter generally give you idea. This scatter, from this scatter generally you need to find out. You see what is your A, what is your this is generally called this is not A. I have considered this is actually what is called CF front part, and this is generally considered as C rear part. So from the crater you can find out this CF and CR, and here also you can find out what this A value. What is the A value? What I am telling, understand?
Yes.
So these
Yes,
three
sir.
parameters you can find from here. And to get the B value, what is the B parameter? What you need to do? You need to take a cross section. Let this is your x cross section. You need to cut it. So after cutting, what happens once you cut it, and once you generally what it's called do the etching operation, generally generally for steel
Mhm.
material we use nitrile solution. Can you recall nitrile solution?
Yes,
Nitrile
sir.
solution I have already told you. Generally for
Mm.
checking the, first of all you need to cut the section in well
Mm.
any weld region. Once you cut the things, you will see your weld bit cross section which is look like this. There is a uh, 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 top bit, you can say that top bit is called top reinforcement, and this
Yeah.
bottom side also there is some extruded portion is
Mhm.
there, that is called bottom reinforcement.
Okay.
Bottom reinforcement, what I'm telling, understand?
Yes,
So
sir.
for finding out the V value, what you need to do, you need to take the distance from this top surface, whatever the top surface is there, from top surface to bottom of the well bit. This is generally called B. What I'm telling, understand? This is called B. So you already
Yes, sir.
got what is your A
Yeah.
value, B value,
B,
CF
C,
value, and CR
C, R.
value. All the things you got. Correct? So these
Yes.
things you
Yes,
can
sir.
easily calculate using this, what it's called experimental bit geometry. That's why
Mm.
for a particular welding geometry, welding operation, first and foremost thing you need to decide your this A, B, CR, and CF, these parameters.
Okay.
What I'm telling,
Okay.
understand?
Yes, sir.
And this parameter how to define? For the parameter you need to define by using this method. I have already shown these things in the
Yeah.
experimental way also in my present in my lecture, very clear way. What I'm telling, understand? So A, B, C, D, once you find out, rest of the things is your welding parameter
Yes.
only. This Q is generally what is called V into I,
Yeah.
welding voltage into current. What I'm telling, understand? And
Mm.
where the
Yes,
welding
sir.
velocity is coming? Welding velocity is coming
Mm.
in this equation, zeta. Whatever the
Yeah.
zeta is
Yeah.
there, this moving coordinate, in this zeta your welding velocity terms is coming. What I'm telling,
Okay.
understand? So interesting,
Yes,
everything
sir.
is connected with each other. What I'm telling, understand? Now
Mm.
this thing generally you need to do what happens using some software package, either ANSYS
Mm.
or Abacus. Now,
Okay.
ANSYS and Abacus software package, what is these things? I think you know very well, Praveen. ANSYS or
Yes, sir.
Abacus, ANSYS or Abacus software is based on generally what is a finite element numerical method.
Correct.
So what happens in any other what is called session, actually I'll discuss those things also little bit in details. Finite element,
Oh,
generally method, what is the basic concept required, what are the steps generally you need to use to do the simulation. I'll just present here in live session itself. Generally, first of all, you need to make the modeling part. Then you need to discretize the model. That is
yeah.
called meshing. So after
Correct. Yeah.
meshing, you need to apply the before meshing itself, you need to specify material property. Okay.
Yeah.
Then
Yeah.
after specifying material property, you need to mesh it. After meshing, generally you need to apply boundary condition,
Boundary condition.
thermal boundary condition. Then this moving coordinate heat source you need to apply. What I'm telling,
Yeah.
understand?
Yes,
And
sir. Yeah.
after once you apply the moving coordinate heat source, then what happens? You can after that, if you solve it, then you will get the thermal results. Okay. After that,
Correct.
generally thermomechanical analysis is required to do for prediction of residual stress, distortion, then plastic stain, thermal stain, and all the things that also you can predict. Okay, that related
Yes, sir.
things also, that concept also I will discuss in details in this course. Okay, thank
Okay.
you, bye.
Thank you, sir. Yeah. Thank you,
Okay,
sir.
thank you, bye. Thank you,
Yeah. Thank you, sir. Bye, sir.
thank you, bye. Thank you, Praveen.
Okay, sir. Bye. Thank you. Thank you.
Any other queries? Do you have? If you have any other queries, you can ask me. If you don't have any other queries, let's see. I think no further queries are available. So little bit I am just discussing I was discussing about this course. I was telling this course actually covers very high fundamental things related to welding, that you can say. So I have already told you that in this course I have also derived I have also delivered lecture on fundamental of different types of heat source model and their derivation, and also I have discussed their importance also. In this part, generally the content are generally derivation of Goldberg double ellipsoidal heat source model, then derivation of semi ellipsoidal heat source model I have done. These are all generally three-dimensional heat source model. Apart from this thing, I have discussed about a Gaussian distribution of heat source model and its derivation, and some other heat source model also, which are latest development heat source model, you can say. One is called Avogadro shape heat source model. Another one generally is called hybrid shape heat source model. This hybrid shape heat source model have a wide application in case of high power density, what is called welding process, especially laser beam, then what is called electron beam types of welding process. So after completion of these thermal fundamentals related things in details, we also covered in thermal analysis the common heat treatment processes used in welding. So in common heat treatment process in welding, the content of these topics are generally here. The content of heat treatment process are like preheating process I have discussed in details. Then I have also discussed about preheat temperature, uh, how it is calculated, and what it's called, what is its importance, If it will be different, then what happens? What will be its effect in final structure of welded joint? That related things in details I have discussed. I have also discussed about interpass temperature, then some other common heat treatment process related thing in details in this course, like annealing, normalizing, then tempering and aging process. So these are all different types of heat treatment process I have discussed. And finally, I have also give the lecture on post-weld heat treatment topics. Okay, so here I have discussed the different types of post-weld heat treatment process, like what it's called post-heating and stress relief related topics in details. Okay. Now in this course, the second topics you can say is the detailed fundamental of design and analysis of welded joint. So in this second topics, I have covered the this importance of design of welded structure in details. What are the principles generally involved for designing a welded structure in details I have discussed. The content of this lecture generally are principle of sound welding design. Then I have discussed about allowable stress and factor of safety related concept. Then after that I have discussed about welded joint subjected to different types of loading condition, like torsional types of loading, then bending types of loading, and if it is subjected to different types of combined loading, then how to design that welded structure. That related things in details I have discussed in this course. And here I have also covered a very important topics that is called shear flow based fillet weld joint. There I have discussed about what is shear flow, what is the resultant shear flow, and based on this concept of shear flow, how to solve a combined loaded welded structure in details I have discussed in this course. And the final topics of this course is, you can say, weld fatigue analysis. This is a really very important topics which I have covered in this course in details. Here I have started actually in this fatigue, and I have started from the scratch of the fatigue topics. And after that, I have covered at the end of this course in details what are the different types of fatigue method, fatigue analysis method generally used to analyze welding related structure. That related things in details actually I have discussed in this course. Little bit I am just briefing actually what are the fatigue related topics I have covered in this course. So in the fatigue analysis topic, I have started from very simple basics and ended with very highly advanced details of fatigue analysis of welded structure. The content of the fatigue analysis are like here. Initially I have started with basics of fatigue life prediction. In this part, generally the content of lecture are estimation of endurance limit by approximate method, then determination of stress life prediction problem, NOS sensitivity factor, some other important NOS notes which are highly essential for fatigue analysis, which included like the effect of welding of fatigue life. Here I have also covered fatigue of typical joint, stress concentration factor for some welded joint, and solve different problem on fatigue analysis. Here in this course I have discussed in different types of fatigue analysis approach which are commonly used in welding joint analysis. Here I have covered what is called LEFM approach, linear elastic fracture mechanics approach. Here I have also covered some very important global and local fatigue analysis approach, which are actually called hot spot stress method. then nominal stress sport, nominal stress approach. Then I have also covered notch sensitivity or effective notch stress approach. So that related things in details actually I have covered in this course. So and I have shown which content is, you can say, more effective for what it's called weld fatigue analysis. So that related things in details I have covered in this course. So I think no further queries actually are there. So if there are no further queries, then what happens? We can quit today. In next session also there will be another 1 2 live session will be there. So in that session also we can discuss further details if you have any queries. So thank you today for this live session. Thank you, Praveen, for your very interesting queries. So I